our Team 4, the Radar Demonstration System team. We are in the ECE department, sponsored by Michigan Tech. Our problem statement is to demonstrate radar in an educational setting with live observable feedback. We can do this in a variety of ways, like making a mobile device, having audible or auditory or visual alerts, creating an image, or having physical effects due to sensing.
So for building a radar, we start with adjusting the different outputs from the transmitting and inputs from the receiving antennas with traditional analog components like mixers, amplifiers, modulators, and noise filters. When filtered or mixed, these components help compare data from the antennas into different components of real-world objects.
Here is our system design. The program gene the radio controls the SDR with transmit and receive paths. When transmitting, we attenuate and amplify before sending the signal out, and receiving, we amplify and attenuate to protect the SDR. The LNA will power the regulated to 5 volts. This is our CW radar holographic gene radio. On the transmit side, we generate a cosine signal and send it to the SDR at 2.4 gigahertz. On the receive side, the signal is first cleaned on a DC blocker, then mixed with a reference tone to bring it to baseband. We then filter and downsample the signal and finally take an FFT to extract Doppler information.
Frequency modulated continuous wave radar uses a chirp. We built this chirp by using a signal source of a sawtooth and put it through a velocity controlled oscillator. This creates the chirp where the wave starts off slow and then gets faster. The frequency modulated continuous wave radar flow graph is similar to that of the continuous wave. However, there is an added path. This is the argmax, which then goes through a short flow add constant and multiply constant, which is the equation to find the Doppler effect on the frequency modulated continuous wave received data.
So when building our radars, we of course needed to confirm that the data from our radar setups was accurate with real world characteristics and reality. To this end, we fully completed the continuous wave radar setups, experimentation with different antennas, the ultra wideband and directional ones, as well as with and without amplifiers.
If we had more time, we would like to make a mobile device using a Raspberry Pi instead of the computer. This way, they can pick up the radar demonstration system and walk around with it instead of being stuck wherever you have a computer. Additionally, we'd like to implement frequency modulated continuous wave with 2 HackRFs. We would like to thank Michigan Tech for sponsoring our design project and Dr. Pinar for all of his advice as our advisor.